Ma'am, you're on mute, ma'am. Your voice is not audible.
Ma'am, is your screen visible?
Yes, ma'am. Your screen is visible.
Okay. Now first we'll start with an operator. First we'll explore the fundamental operators in Python, including their usage and examples. Okay. Operators are a special symbols or keywords that carried out operations on variables and values. I think I have learned in last class about variables. So here operators are of two forms. One is unary operator and other is a binary operator. Unary operator deals with single operand and binary operator deals with two operand. Okay, Python has various types of operators for some specific task. For arithmetic operator calculation and logical operator for comparison. These are the types of operators: arithmetic operator, comparison, logical, assignment, bitwise, and special operator. First, we'll move on to arithmetical operators. Arithmetical operators allows us to perform some mathematical operations like addition, subtraction, multiplication, and division, as all know. Okay, here addition. Addition is combination of two numbers. See, for example, 3 is one operand and 2 is other operand. So these both operands are combined with a special symbol that is called as a operator. Okay, here 3 is an operand and 2 is an operand. These two operands are combined with a special symbol called as operator. Likewise, for subtraction, subtraction finds a difference between two numbers, and multiplication multiplies two numbers, and divide is to divide the first number by the second number and returns floating point. In division, it returns floating point. Okay, that is 0.0. In this example, there is 5.0. That is a floating point number. And modulo returns the remainder of the division. In modulo, will return the remainder of the division. And exponential, as you know, it rises one number to the power of another number. That is exponential. Next is floor division. Floor division divides and rounds the result of the whole number. Okay. So difference between division and floor division is division gives the floating point number, but floor division rounds the nearest whole number. Okay. This is an arithmetic operator. Now we'll see the program for arithmetic operators. So here I've given a equal to 7. That is, a is a variable. So for this variable a, I'm giving a value 7. Okay, this is an operand. This is an operand. Okay, here like this, b equal to 2. So b is a variable and 2 is a value. So I'm assigning the value 2 to the variable b. Here I'm just giving a print statement. This is a predefined statement. Print sum equal to a plus b. Okay. Next, as for subtraction, multiplication, division, floor division, modulo. Here I'm giving this code for everything. Okay. Here addition. First addition, what it does is a plus b. So value of a is 7 and value of b is 2. So 7 plus 2, you'll get answer 9. It is reflected here. Okay. Next, subtraction, a minus b. In 7 minus 2, as you all know, that is 5. And division, a divided by b. Here multiplication, that is 14, and division, that is 3.5. It gives floating point, so 3.5. Floor division, that gives the whole number, so just 3. Modulo gives the remainder, so that is 1. And the power is just giving a power value, So 7 power 2 is 49. Okay. Next, we will go for comparison operator. Comparison operator helps us to compare two values to determine their relationship. This operator returns Boolean values. That is, Boolean is said to be true or false. And these are the comparison operator: equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. These are all the comparison operators. We'll see a program for this comparison operators. Okay, just A equal to 5. Like I said previously, A is a variable, and 5 is a value. Value 5 is assigned to a variable A. Likewise, B equal to 2. 2 is a value. So this 2 value is assigned to the variable B. And as you have known, this inbuilt statement, so print equal to A equal to B. Just it checks 5 equal to 2 or not. If it is equal, then it returns true. If it is not equal, then it returns false. Here, 5 is not equal to 2, but in our condition, they have given 5 is equal to 2. So it will return false. Likewise, it checks for not equal to, greater than, less than, greater than or equal to, less than or equal to. And here is the output for the event statements. Okay. Next is a logical operator. Logical operator allows us to combine multiple conditions or reversing them. Okay. Logical operators works with the Boolean values. If the given condition satisfies, then it returns true, or else it returns false. Logical operators are and or not. These are the logical operator. Returns true if the both conditions are true, and use returns true if the both conditions are true. Or means returns true if at least one condition is true. Not is just reversing the value of the condition. Okay. Note it down. True if in this and true if the both condition are true. Okay. It returns true only if both condition are true. Or returns true if at least one statement is true. Not is just reversing the result. This is an example of a logical operator. Here I am giving just true and true. Okay, true and true is true. True and false is false. If both condition is true, then only it returns true. If one condition is false, then it returns false. Next is logical operator. At least one is true, it returns true. So see here, true or true. It returns true. Then next is not. Not is just reversing the statement. If it is true, then it returns false. Okay. This is the working of the logical operator. Next, we'll go for an assignment operator. Assignment operator not only assigns value to the variable, but also modifies them based on the operations. Okay, it just not only assigns the value to the variable. Okay, assignment, as we think, assignment operator is just assigning the value to the variable. Not it does only not only that, but it also does the modification based on the operations also. Okay. These are the assignment operator. That is equal to, plus equal to, minus equal to, multiplication equal to, division modulo. In this, every arithmetic operator will be giving an assignment operator. Here x is equal to 5. So this 5 is just assigned to this variable. Value 5 is just assigned to the variable. Here x plus equal to 3. That means x is equal to x plus 3. Okay. The abbreviation of this is x is equal to x plus 3. The expansion is just x is equal to x plus 3. Okay. Here x minus equal to 3. This expansion is x is equal to x minus 2. Okay. Then as like for multiplication, division, modulo, everything, this concept is same. Okay. Next we'll see assignment operator. Okay. See here I am assigning a equal to 10. So now for this variable a, the value 10 is assigned. Next b equal to 5. So this value 5 is assigned to this variable b. Okay. Next I'm doing a plus is equal to b. So how it expands? A equal to a plus b. Now the value of 10 is given to this and value of b is given to this. So now a equal to 10 plus 5. I'm here printing a. So the value will be 15. See here, after, before I'm here I'm giving just, I'm just printing, I'm just printing a value. I'm just printing a value. It gives an output as 10 because value of a is just 10 here. After calculation only, the value of a is moving to 15. Okay. After, if I give here print a, it will updated value only, it will be displaying here. Okay. Here just I'm giving a equal to 10. Next is bitwise operator. Bitwise operator performs operation on binary representation of number. Here, bitwise operator just performs the binary representation of and number. Okay. For example, if 5 and 3 result is 1 because their binary and operator only matches at the least significant bit. Okay. If for example we are giving 5 and 3, it results in 1 because 5 is converted into a binary value and 3 is converted into binary value, and operation is this. After AND operation, the value provides 1. Okay. So bitwise operator manipulates individual bits of an integer. So it's having AND or XOR, not left shift and right shift. Left shift means just adding number of zeros after the given digits. Right shift is just discarding the rightmost bit. Okay. Left shift just adds 0 to the right after the given number. It adds 0 to the rightmost part. Okay. Right shift, what it does is it shifts the right, discards the rightmost bit. Rightmost bit will be discarding in the right shift operator. Okay. Here we will see the example of the bitwise operator. Here a equal to 5. As I said before, 5 is assigned to a variable a and b equal to 3. 3 is assigned to the variable b. Here I am just doing AND operation, bitwise AND to this a and b. Okay, so 5 and 3 is now doing AND operation. Okay, if I do AND operation first, 5 is converted to zeros and ones and 3 is converted to zeros and ones. Now I am adding the both. In AND operator, what will be seeing? If both it is true, then we'll get true. If either one is false, the answer will be also false. So here output will be 0, 0, 0, 1. So the answer is 1. Okay. And next is NOT operator. Here what it does is it just takes the 2 complement of this 12. Now I am just assigning a equal to 12. So the value of 12 is given to the variable a. Here I am doing b equal to negation of 12. So what it does is it takes the 2 complement and stores the value in the b. So we're getting an output as 13. Okay, next is a special operator. Special operator is said to be an identity operator and membership operator. This two operator is under a special operator. Okay. What identity operator does is it used to compare object reference. It has two operations, that is and is not. What is does is returns true if both variable points to the same object. Okay, it returns true if both variable points to the same object. Is not returns true if both variable do not point to the same object. Okay. Next is membership operator. This membership operator used to test the membership in the sequence. Okay. Here it has two operations, that is in and not. In returns true if the value exists in the sequence. In not returns true if value does not exist in the sequence. Okay, now we'll see an example for this. This is identity operator, that is num1 equal to 5 and num2 equal to 5. Here value 5 is assigned to num1 and again value 5 is assigned to num2. Here I am printing num1 is num2. That is whether num1 is same as num2. If it is same, it returns true. If it is not same, it returns false. Okay, here num1 is 5, num2 is also 5. So both are same, so it returns true. Here, next statement, if you see, num1 is not num2. So num1 is 5 and num2 is not 6, so it returns false. Okay, clear? This is a concept of operators, Python operators. Next, we go for conditional statements. Okay. In conditional statements, there are main type of statements. That is, if else, chained, if, like that. There are main types of statements. We'll see one by one. First, we'll go with conditional if statements. Why we are using if statement? Okay. It executes code if a condition is true. We'll be giving one condition. If that condition is true, then the block of statements will be executed. Okay. If the statement is not true, it comes out of the program. This is just a if statement. Okay. This is the syntax of the if statement. That is, just we are giving if. In this if block, we are just giving a condition. If this condition satisfies, the code block is executed. Okay. So if statement is like a gatekeeper. Okay. If statement is like a gatekeeper, it checks a condition, and if it is true, the code inside runs. Okay. It is like a gatekeeper. If it is true, the code inside runs. Others just exit of the program. Okay. See, for example, if we want to check if someone can vote, okay, we use if to ensure their age is 18 or older. See, here we have given an example. No? In this example, what we have done is if we use if to ensure the age is older or not. Here we have given one statement. If this age is older 18 or older, we are checking here. If the condition is true, then it is open, we are eligible for voting. Okay. And next is if else statement. Okay. That's alternate option when condition is okay. See here, if else statement expands the decision making statement. It is like asking what if the condition is not true. See, in if statement, we just said if condition is true, the program code will be executed. If it is not true, what will be doing? So for that, we'll be doing if else statement. Okay. For example, here we have given odd or even, right? If a number is odd, then if statement is okay. If number is not odd, then what will be doing? We'll go for else statement. If we check whether a number is even or odd, we use if for one scenario and else for alternate scenario. It ensures that no matter what function researches, the program knows what to do. Here, okay. See, this is syntax. So we are giving if conditions. This if condition is okay if block of code is executed, else the false block is executed. Okay. Next is chain. Sometimes there are more than two possible outcomes. Sometimes it may have more than two possible outcomes. For example, when grading a test, a student could receive A, B, C, or even fail. In such cases, it uses if then look else to handle multiple conditions. Okay. So this is a syntax of else. Okay. If condition is given, here for block. If the statement is true, this for block will execute. If this statement is false, it comes for if statement. Okay. In this else statement, it checks the condition, and if it is true, this code block is executed. This is also false, then it comes for last else statement. This code block will be executed. Okay. Here we are checking the score of a student. Okay. We'll see this example for this conditional statements. See, we are checking if the number is positive or not. Here, this condition. If the number is not positive, then it goes to next condition. If this number is not positive, not negative, then it comes for this condition. Okay, so I am giving here three conditions. First condition is to check whether the number is positive. The next condition is if it is not positive, and next condition is it is neither positive nor negative. Okay. Here in if condition I am given this x is greater than 0. If it is greater, then it is positive. If x is less than 0, it is not positive. If I am giving a number 0, it is neither a positive nor a negative. Okay, here I am giving a value x is equal to 4. So 4 comes under first condition. So x is positive. If I give here minus 4, it comes to a not positive number. X is for iteration. Simple merry-go-round. Okay. It is like a merry-go-round. It keeps going on as long as a certain condition is true. It keeps going on as long as a certain condition is true. Until the condition is true, it repeats itself.
I'm sorry
Yes.
for the disturbance, ma'am. Your voice is not clear.
Is it audible now?
Yes, ma'am.
A while loop is like a merry-go-round. It keeps going on as long as a certain condition is true. Okay, if a certain condition is true, then it executes the program until a condition gets true. It goes around and round until the condition gets true. It repeated action. Okay, this while loop is repeated action. while the condition is true. And here is the syntax of this while loop. Okay. While I'm giving this condition until the condition satisfies, this code block is executed. Okay, here I'm giving count is equal to 0, while count is less than 5, and the count value is printing, and after this count is incremented, again it checks the condition, and the count value is printed, and it comes here, and here the count value is again incremented, and it checks the condition, and this print is the value will be printed. Again, this value will be coming here and it will be checking the condition. And after the condition checks, it will, when this condition gets false, the program will be executed. Until this condition is true, it comes down, the value is incremented, and then it checks the condition. It comes down, value is incremented, again checks the condition. Okay. Next is for loop. See, when we are using for and while, when the exact value is known, we'll be using for loop. When exact value is not known, we'll be using a while loop. Okay, this is what the difference between for and while loop. See here, for loop, what it does is the for loop is like walking down a line of objects. Okay, it is like walking down a line of objects. You start at the first object and it goes on. Okay. Iteration is over a sequence. It may be in list or range somehow. This is the syntax of the for loop. That is for variable and sequence. The code block is executed. For I in range of 5. So this I variable has a value of 5. So till the condition satisfies, this I will be printing. Okay. If it comes to 0, then it prints 0, then it increments, then it goes to 2, then it goes to 3, then it goes to 4, and 5. Until 5, the condition will be processing. And here is an example of for loop and while loop. We have for I in range 5. So here I'm printing I value. First, it will start with 0. It comes into 0, then I value will be 0. Next, it goes and checks the condition. Next, it goes to 1, and it comes and prints the value 1. Then it will go here, and it will print 2, then 3, and 4. If we are given a range 6, then it prints till 5. Here we are given a range of 5, so it comes to 0 to 4. Next is while loop. First, it starts count is equal to 0. So, count variable is having a value 0. Here, we are giving a condition while count is less than 5. So, it goes beyond 5, the condition will be executed. Until 5, the condition will be checking. Okay. Here, the print count is less than 5. So, print count value, count plus is equal to 1. So, what the meaning of it is count equal to count plus 1. Is it we have already seen in the assignment operator? No, count plus is equal to 1 is count equal to count plus 1. So count value will be getting incremented and printed. Okay. First it checks count value is 0. If 0 is less than 5, yes, then it prints count value, and again it comes here and the value is incremented. So it goes to 1, and the 1 is less than 5. Yes, so value is printed, and again it is incremented, then it goes to 2, and again it incremented, and 3, 4. It prints only till 4. Here we have given less than or equal to, the high value will be printed, it is not equal to, then it will be 20. Okay, here next we will be printing this while statement and we print. Here in iteration we have given for loop, while loop, and do while loop. Okay, difference between for and while is, in for loop, if we have known the exact value, okay, exact condition and exact value, will be going for loop. If we doesn't know this exact condition, will be going for while loop. Okay, now do while loop. What is do while loop is, while and do while is similar. In do while loop, first it checks the condition and then it go for. Actually, in do while loop, first it prints the value and then checks the condition. In while loop, it first checks the condition. Okay, difference between while and do while loop is, in do while loop, first the value is once printed and condition is checked. In while loop, first the condition is checked and the value is printed depending upon the condition. Okay, in do while, it just the value is printed before it checks the condition. And next is break, continue, inference. This also comes under the iteration. Here break. In a loop, break is like filling the just or emergency stop. We are just emergency stopping a condition. In this, we'll be using a break statement. It ends the loop immediately. If we do break statement, it just ends the loop immediately. So for that only we are using break statement. Next is continuous statement. Continuous statement is like just keeping one step in the dance. Okay. Just for example, we are just dancing. In this dance, we're just keeping a one step. That is like a continuous statement. It just ignores the current iteration and moves to the next. And pass is like a placeholder. It does not do anything but allows the loop to continue. Okay. In iterations, there are for, while, and do. The three are one process, and next is break, continue, and pass. Break is just ending the loop immediately. That is break. Continue is just ignoring the current iteration and moving to the next one. That is continue. Next is pass. It does not do anything but allows the loop to continue. Okay. These control gives a flexibility to manage a loop efficiently. By using this iteration, that is a looping concept that will be very flexible to manage your loops efficiently. So we will see this example for this. break. Okay. Same here we are giving the condition. If the statement is true, then as like it will be printing in how we have done this working in while loop. No, the same working is given for break statement. If the condition is satisfied, it just immediately terminates the program. See 0, 1, 2, 3, 4, 5 is printed. After the condition satisfies, break is given. Okay. Next, we'll move on to a topic functions. Actually, we'll see an overview till what we have learned now. First, we have seen about operators. Okay, this is a basic topics. First, we have seen about operators. In operator, we have seen 6 types of operator. That is arithmetic operation, comparison, logical, assignment, bitwise, and special operator. In arithmetic operator, we'll just addition, subtraction. As you have known earlier, this will be done in mathematical operations or done in arithmetic operator. Next, we'll go move on to a comparison operator. Comparison operator is just comparing, but in comparison operator will return only Boolean values. That you have to make sure, okay? In comparison values will be just returning the Boolean values, okay? Next is logical operator. In logical operator is also will be returning only Boolean values. If the condition satisfies, it returns true. If a condition does not satisfy, it returns false. Next is assignment operator. Assignment operator is not just assigning the values, it also modifies them based on their operations. Next is bitwise operator. Bitwise operator just performs the binary operations that we have seen now. That is a bitwise operator. And next is the special operator. Special operator actually most will be using this arithmetic operations only. Arithmetic operations and comparison logical. These are the most operator will be using. Okay. Last is special operators. In special operators, there are 2 types, that is identity operator and membership operator. Okay. These are the overview of operators. Next, we have seen about conditional and iterations. Okay. In conditional, we have seen just if statement and if else and ellipse. Like that, we have seen an if statement. This condition just it satisfies the condition, it returns true, or else we'll go for a next statement. Okay. Conditional and iteration. There are 2 types. Conditional is just if statement, and iteration is while, do while, for, and break, continue, pause. Okay. Next, we'll move on to functions. See, why we are going for functions is, see, we have to reuse the code. Okay. For example, if you are doing calculation, like calculator program, okay, what will do? In calculator, sometimes we'll add, sometimes we'll multiply, sometimes we'll divide. Whatever we want, we'll do this calculation. If you have to add a number 4 times, what you'll do? You'll again do, you'll do a code for 4 times. It is so tedious and the code will be so long. And if it gets some error, you have to rectify it. So it will be very tedious. So to reduce that, what we are doing, we'll just call a function. Okay, code can be reused many times. The wanted code can be reused many times. So we are going for function concept. Okay. See, without function concept, the code cannot be used. So if we have to do a specific task for several times, the code has to be given several times. So if we give the same code several times, what it will happen? It gets time is also wasted and it will be code gets so longer and it occupies more space. So these every drawbacks are there. So to reduce the code, we are going for function concept. Okay, the function is a reusable block of code that performs a specific task. Okay, function is a reusable block of code. Okay, function is a block of code. Actually, in programming, if a condition satisfies, then you use a block of code. Okay, likewise, here is also a block of code is there. That block of code has to be reused many times. To reuse many times, they will be using a function concept. A function is a reusable block of code that performs a specific task. Okay, function is a block of code designed to perform a specific task. Function allows you to encapsulate logic into reusable units. Function helps to improve both reusability and reusability. Okay. By defining a function, you can avoid writing the same code repeatedly, which makes your program more efficient. Okay. By using function concept, you can write a code repeatedly, avoid writing code repeatedly by using function. By that, your program will be ensured effectively. So why we are using function? Advantage of function is reusability. Reusability means write once, use many times. Okay. Reusability means write once and use many times. Next is modularity. The reusability, modularity, the readability, and maintainability. And here reusability. Reusability is writing once and it can be used many times. Next is maintainability. Large number of programs, that is bigger program, is break into smaller number of features and usable tasks. That is modularity and readability. Function allows you to use descriptive names for tasks. You have to use only descriptive names. If you are giving say, for example, a unit of saying calculator program, you have to give the function name is just addition. You should not give A, B, C, like that, and then you should not give. You have to give readable names. If you are coding a program, and if you leave that job to other people, they should also know what they will have been adopted. So understandable, readable names only have to be given for functions. Okay, for usability. Easier to detect and update specific type of the code. These are the advantages of the function. First is reusability, modularity, readability, and usability. Okay. Next is a syntax for the function. This is the syntax for the function. Here the first is a keyword. This keyword should be followed by the function name, and parameters is not mandatory. Okay, if you are passing a values, then we have to give the values in this parameter. If we are not giving, then you just leave this parameter that is raised to be given. And the code is given in the functional body. Return value. Return value is also optional. If you are returning some value, then we have to give a variable here and return that value there. Okay. If you are not giving a return value, just your printing, then this return value is not necessary. This keyword is mandatory in function. Only if keyword only this function will be defined. Okay. This keyword should be followed by the function name. This is mandatory for the function. The explanation of this syntax is the that is a keyword used to define a function. Next is function name. Function name is the name of a function. Okay. That I have said now, if you are doing for the calculation calculator, that the function name should be addition. If you're giving an addition code block, then the function name should be addition. If you're giving a subtraction code block, then the name of the function should be subtraction. Likewise, what is the operation variable? Whatever the location is given, the code block should be similar. Code block and name of the function should be similar. Okay? Next is parameter. Parameter that is optional is a before now. Optional variable function into a function. If you are mentioning a parameter, then you have to give a parameter. If there is no parameter, then you can leave it as a int. Okay. Next is a return. A return is an optional statement that returns an element from the function. Return is an optional statement in 27. Come down to you have to a return keyword with the value. If you are not return, you don't want to mention anything. Okay, return is not necessary. This statement is needed. See, which is simple example for a question. Okay. Here, if you take a depth keyword, that period is followed by the breed. D is the function name. Okay, and this begin operation from given this code, that is a keyword. This keyword is followed by the breed function name and since name is a parameter. Here is given a parameter, the parameter results and value is the value is passed here in here. Okay. So, what we here I can say again. So this can be printed from printing from hello, this name will be passed here. Please read is ours. So hello, hello should be printed here. Okay. This is a parameter. is a parameter. Okay. So it is name and given a value as allies. So wherever name is given, if this name parameter is given, correct, the value always should be replaced. Okay. This paragraph is without converting with the parameters. If we get it, this green is without return value, but with parameter. What parameter I have given is name. For this name, I have given value alias. So wherever I am giving a name parameter, the name parameter will be replaced by the value alias. Okay. This is before return value. Next program is with return value and with parameter. Okay. With parameter and with return value here and here. As you know, this is a keyword. This keyword is followed by the square. Square is a function value, and here reaction is a parameter. Okay, that is a keyword. This keyword is followed by the square. Square is a function name. This function name is followed with the n. N is a parameter. Okay. Here, in this function, I am giving a set of traits. That is, n star n is a code I am giving. This code will return some value, right? So this value should be written in this percentage. Okay. This two line is a function. This two line is a function. So should be followed by function name, and you are returning some value written keyword must be here. And if you are giving some parameter in the bracket, parameter parameter we did. That is known as the function. Okay. If you are giving a return, a variable must be mentioned here, and the return value should be replaced in this result. Here, result is equal to square of n. Okay. Here, n is replaced with the value 5. N is replaced with the value 5. So, square of 5. Here, I'm calling this function. This is a function call. Okay, this is a function call statement. Here, I'm calling square of 5, square of 5. So, where it goes, where this after saying this, result is equal to square of 5. It moves to this statement. X square of 5. Okay, next it comes to this statement. So, in this case of given 5 is replaced. So 5 star 5 is 25. So this 25 is placed in this result, and this result is neutral. You will be getting equal to 1. Okay. It's the other example of definition. We have seen already for conditional statement. So the same will be seen in the see here. That is a function name. I have given the function number. That is forward to the sorry, that is a keyword. This keyword is followed by the function name. Function name is GFG. Okay. And this parameter is X. Okay. This x is equal to 4. This value 4 will be equal to here. Next, program will be entered into this line. First program person will be entered into this line. X is equal to 4. Okay, it will be okay. Value 4 is assigned to x. Next, it comes to this line. In this line, GFG of x is there. Okay, it will be okay something. GFG is the function. X is equal to 4. So GFG of 4. It will search for GFG. Where is GFG? And it can search in both of this line. Okay. Here they are given a function. Okay. Here GFG of 4. And it checks here. It comes into this profile. This is a plot of 4. And given this, for this function, this is a plot of 4. Okay. If it checks, if 4 is greater, yes, it is greater, then it is a positive number. Here, this condition is false, here, this condition is false. It will not see this condition. If we are giving here minus 4, it checks here, this condition will answer this way. Next, it goes for ellipse state. Okay. If I am giving x is equal to 0, it does not check this statement. Statement is also false, and ellipse statement is also false, so it goes for else statement and it can see. So in this example also, we don't have as the we have seen the opposite figure. Here is the function one. This function one is followed by a comma b. A comma b is a parameter. And a comma b is a parameter. Here they are giving a parameter at different values. Here this parameter at this return x. Here return a plus. First, if you're giving this code, first cursor comes to this line. Okay, first cursor comes to this line, which is result is equal to f b comma 2. So here the sum function we have mentioned in the program, so you can search for r. If the finds r, it goes here. Okay. R a comma b instead of a comma b, 3 comma 5 is replaced. And instead of a 3 is there, and instead of 3, 5 is there. Then 3 plus 5, it it calculates and it keeps 8. Okay. Here return statement is there. So return 8. Where it will be coming? Here it is check. It returns 8. It will be printing in this result. It stores the result variable and this result will be printed here. Your function can accept input numerous parameters away from the program with different values. The function can accept input numerous parameters away from the program with different values. Your function can return as an array using the return trigger, sending the result back to the caller. If here two things are there, calling function and calling function. Calling function is we are calling a function and it is
Ma'am,
one.
ma'am, your voice is not clear, ma'am, again.
So is it okay now?
Can you make it a little bit louder, ma'am? Your voice is not audible, ma'am.
Is my voice audible?
Yes, ma'am.
We are seeing functions with return value, and the function can return a value using a return schema to give the result of the requirement. Here we have called the function as called state. In calling function, first the function is created the calling function, and after two steps, and the function has been called, so it goes for call function. Data type state process and fourth block is being executed. The function can return a value using a return keyword, sending the result back to the server. Okay. when you call a function, the program executes the code inside the function, and if the function has a result, it will give the result back to the um, variable where the function is called. Next is the scope. There are two scopes of function, that is local scope and global scope. In local scope, variable declared inside a function or local to that function. If you are using a variable, that variable will be working only inside the function. It cannot go outside the function and run. If you leave inside the function, it will be working only inside the function. Next is a global scope. Global scope is variable declared outside any function or in the global scope. You can access them inside a function but need to use a global keyword to modify them. See, a difference between local scope and global scope is local scope. If a variable is given in a local, it will be accessed only within a function. Other than that function, you cannot use this local scope variable. But in global scope, that assigned variable, the global variable can be used in all the functions throughout the program. But you have to give a global keyword. Without that, it will be not accepted as a global variable. This global variable, if you are declaring, see, you are giving a two function, that is addition function and subtraction function. You are declaring the variable outside both the function, so you can use an addition function in both the subtraction function also. Okay, if you are giving a variable in addition function without global scope, it will be working only in the addition function. You cannot use a subtraction function. Okay, if you are giving that variable in a global scope, you can use both addition and subtraction function. If the function has a detailed value for its parameter, you can call it without providing those values and it will use the defaults. Okay, without, if the function is a default value, if a function is having some default value, you can call it without providing those values. Okay, because this default value will assign to that variable and the function will be processed. The function concepts in Python is very powerful because they can be passed around the given to other functions, making the program very utilizable. The main purpose we are using the function is the main purpose of this is improve code readability and reduce redundancy by encapsulating logic into reusable pieces. Always whenever you're giving a meaningful names, actually I have said this before, you have to give meaningful names for the functions and parameters. So it's clear that you're doing when you are a someone executing this code. See what this code you're giving, not you're the person, not only are you be using this code will be shared with everyone. If you give meaningful words of it, everyone can be it will be readable. A function in Python is a specific class before code is it defines a set of instructions that can be executed regularly in the instead of writing a string of codes repeatedly, you can follow the function of previous examples as you want. This is the only thing you have to message. To consider the code, instead of writing the same code repeatedly, you can create a function and use examples as you want. That is called the parameter to customize the behavior on that one use media in your program. This makes the tool more modular, organized, and easy to understand from navigate. So the next is conversion. Today we have seen having we have seen operators, conditional statements, iterations, functions. Here we will be a question concept. A recursion is a process in which functions work itself to break a complex problem into simple smaller problems. Actually, recursion is also a function that curves itself. Okay, the function curves itself. Why it curves itself is to break a complex problem into smaller problems. It's like solving a puzzle by dividing into manageable pieces. A recursion is a programming technique where function calls itself. Okay, usually will be calling a function and the block of code will be executed. That's what we have seen in the before example and before theoretical things. Right? A recursion is function itself calling to solve a problem. That is called as a function. A function that calls itself is called as a recursion, commonly used for programs that can be broken down into smaller subprograms. Here we need two cases, that is base case and the recursive case. Okay. Without base case and recursive case, recursion problem cannot be solved easily. Okay. Here, what is base case? Base case is to stop a recursion. At one particular point of time, we have to stop a recursion. If you don't stop a recursion, the process will be continued till the end. Okay. So here base case is used to stop a program and recursive case is continue till the condition satisfies. Okay. The recursion is also like a function of means. Before the recursive function will be following a function and this collected code will be executed. But the recursion is not like that. If the function is called itself, it is called as recursion. There are two components in recursive function. One is base case and recursive case. The base case is essential to stop the recursion and prevent infinite loops, but a function for itself in the complete parameter is executed as a recursive case. Okay. The recursive function is called the base case to stop a recursion. and recursive is the most self-repeating system includes. So most examples of the factorial of something will be 24%. Like 3 will be a data structure will be used with the functions, no? So the thing factorial will be one hundred will be mentioned this in terms of function. So when you see replace a function, simplest code for programming with repeated structures. Useful for programming like retransfer, backtracking, and dividing from 12. In this example, factorial programmers and retransfer will be using this for the purpose. The base case is a condition that stops the recursion. Without the base case, the function would fall itself indefinitely. Leading to stop the repair. Actually, if you don't give base case, what it happens is the function withdraws itself indefinitely. This leads to stack overflow error. So to avoiding that, we'll be using the base case. What is an example of this recursion? The first cursor comes here, which its none is equal to int input of enter the number. You have to enter a number. So in output screen, first is this will be enter a number. It will be displayed. So I'm entering a number 5. Okay. So the value 5 is now assigned to one variable. So result is equal to factorial of 5. So it will be checking. Factorial is something they have given here that may be an any function. So it goes to a factorial function. So that is a keyword. Factorial is a function name and here is a parameter here. It checks. Here we have given 5. So it checks if 5 equal to 1 or 5 equal to 0. If 5 equal to 1 or 0, it returns 1 and program will be executed. If the given number is not equal to 1 or 5, it needs to be else. Okay. Here return n star factorial of 20%. What is this factorial? This factorial is the function name. So here it is a recursive case. So it calls the function itself. Okay. This is the function. That is if top of n is a function. Here we have declared a function. So factorial is a function name. So this factorial is called again here. This is the recursive case and base case where the function is getting processed. Okay. This is a recursive case. Okay. And here is a base case. And after the processing of 5 factorial, it returns the value to result and result will be printed here. Okay. Here enter the number that is 5. And the print statement, the factorial of number is 5 and the result is 120. So the factorial of 5 is 120. This is the recursion. So this is the program for function by using arithmetic operators. Okay. Here I have given just add and y return exclusive. So Addition is addition function is declared here, subtraction function is declared here, multiplier function is declared here, and divide function is also declared here. Here I given a block of 4 for divide, and block of 4 for multiply, and block of 4 for subtract, and block of 4 for and here I given very two, three, four function, and this is fifth function that is calculated. Here I indicate all the values. Okay. Say operation is equal to the plus, and we are entering this choice. What you need addition or subtraction multiplication. This value is given in this operation. Okay. In this, we need the addition. We need two operators. For the addition subtraction, we need two operators for processing the data. So we want a two operators. Two values I have got, that is number and number. Okay. Then it is performing. If I have given one, addition will be performed. If I have given operation is equal to 2, subtraction will be performed. Operation 3, multiplication will be performed. Operation 4, division will be performed. Okay. And here I have called the calculated function. Okay. So if I remove the plus 1, if I choose 4, then divide will be processed. I have to enter 200. If I press 1, then addition will be processed. I have to enter 2 numbers. Here I have given 2 and 0. Addition is performed. The result will be 2. Is there any doubt in this? We have seen today operators, normal section we have seen operators, conditional statements, iteration, functions, and regression. In afternoon session, we will continue with the other topics.
Ma'am, you are not audible again, ma'am.
Is it okay, ma'am?
Okay, ma'am.
And is there any like in morning session we have seen in operators, conditional statements, iterations, and functions, and regression. There are any questions to ask? Can ask. Remaining topics will be carried out on afternoon session.
Participants, if you have any doubt, you can ask, and also you can use chat window for asking your doubts.
Okay, we'll continue in afternoon session.
Okay, ma'am. I'd like
Thank
to
you.
thank today's speaker, Niveta ma'am, for making the session excellent. And I'd like to thank all the participants for being patient. And all the participants are asked to join in the afternoon session using the same link. Thank you.